Today in this video, we are going to be solving an ancient murder case with DNA fingerprinting consisting of two different VNTR loci. Dating back to the 12th century, there was a famous knight named Sir William Castor who was killed by a cup of poisoned ale. At the time of his death, Sir William Castor was known for his famous victories in battle, alongside having many affairs that kept secret from his jealous Dame Hood, his wife. At the time of this famous knight's death, there was no technology for DNA investigation. However, there was Sir William Castor's hair, crime scene hair samples, and four suspects' hair samples that were later uncovered and kept preserved in archives centuries after. 1,000 years later, a private DNA investigator took it upon himself to study these ancient pieces of hair evidence to see whom among the four suspects were actually the one who poisoned Sir William Castor's ale. Studying our four suspects, suspect 1 was Sir William Castor's Dame Hood, who was named Matilda. Suspect 2 was one of the many ladies who Sir William Castor had an affair with, named Juliana. Suspect 3 is the daughter of Juliana, who knew about the forbidden affair between her mother and Sir William Castor, named Alice. Lastly, Suspect 4 was a loyal knight under Sir William Castor's command, whose name was Sir Simon Wallace. This famous medieval investigation was never solved, but our private DNA investigator has the privilege of using modern DNA technology to study this crime scene evidence using VNTR DNA fingerprinting analysis for our victim and our four suspects. In order to determine who our killer is, our private DNA investigator takes the crime scene hair samples and our four suspects' hair samples from the ancient archives and runs a DNA electrophoresis test to separate the VNTR loci from the DNA. We will now compare each suspect's allele at each VNTR locus to the crime scene DNA and to Sir William Castor's DNA evidence. For our VNTR locus 1, we can see that our crime scene DNA sample has alleles that match the alleles for Alice and Sir Simon Wallace at point 2 and 3 respectively. This means that both Alice and Sir Simon Wallace are still considered suspects in this investigation. For our two other suspects, Matilda and Juliana, their alleles don't match up to the crime scene DNA samples, so they can automatically be excluded from the suspects list. Considering that Juliana is Alice's mother, she has to share at least one allele band with her daughter. At this locus, both Alice and Juliana share an allele band at the third point respectively, with Alice's other allele band coming from her father that is not in the suspects list. For our VNTR locus 2, we can see again that one of Juliana's allele bands matches with her daughter Alice's allele band within the first point respectively. Within the second locus, we can see that this crime scene sample has allele bands at the first and third point. Both Juliana and Sir Simon Wallace can be crossed out of the suspects list because both their allele bands do not match the crime scene alleles. Even though Matilda's allele bands matches the crime scene alleles in this locus, she is still excluded as a suspect because her alleles did not match up to the crime scene alleles in the first locus. Considering that Alice's DNA matches up to the hair samples for each locus, we can infer that Alice is most likely the culprit for poisoning Sir William Castor's ale. Thanks to our private DNA investigator and his help in separating our two VNTR locus from our medieval crime scene's hair samples, a murder over 1,000 years ago has been solved. Thank you for watching this video, and remember that if the DNA alleles match, then that's your catch.